What's up, guys? So we're gonna talk about Ohm's law today. All right. You guys did a little assignment for me for George Ohm, three facts. Today we're gonna talk about his major contribution, what he was recognized for and awarded for, even though it was kind of late in his life, he was still um, he's still recognized for it. So this law is named after him. For Ohm's law, you need three variables. You need three pieces. You need your V. Oops, let me change that up. You need your V. All right. V is for voltage, of course. Right. And oh, my bad. Let's fix that up. I don't know why that's happening. Cancel that. Rewind. Rewind. Let's rewind the whole thing. All right. So for V, you have voltage. All right. And like everything else has a unit, voltage has a unit, and the unit for voltage is V. Sometimes you might see the letter E instead of the letter V for voltage, sometimes, but it's the same thing. All right, then you need V, of course, voltage. You need I. All right, I is for current, and current is obviously measured in amps, letter A. And finally, you have resistance. All right, R is for resistance, and as you might have guessed, in honor of George Ohm, resistance is as a unit for resistance is ohms. All right, now each of these variables has a formula. Uh, the main formula is really here, and the other two formulas are derivatives of the main formula. So let's go with it. Um, how do you know the formula for voltage? Well, if you come over here and you kind of cover the V, right? You cover up the V, cover it up with your thumb or whatever it is, and you're left with I and R. So that's a formula for voltage. Voltage is V is equal to I times R. And your answer will result in volts. Alright, that's the formula for voltage, I times R. Then you have the formula for current. Same setup, take your thumb and cover the I with your thumb so you can't see the I anymore. And what are you left with? V over R, right? So I is equal to V over R. And your answer will be in amps or milliamps, microamps, however you guys want to do it. Third piece, resistance. What is the formula for resistance? Well, the same setup. Cover up the R with your thumb, and you're left with V over I. Alright, so your R is equal to V over I. And your answer will be in ohms, or kilo ohms, or mega ohms, however you want to do it. Alright, so now we're gonna basically um, apply these formulas into an equation and then actually solve for the missing pieces. But before I do that, I just want to talk to you about this guy real quick. This thing called conductance is represented by the letter G, and it's related to resistance. So G is equal to conductance, all right. And the formula for G is 1 over R. 1 over R. Why is it 1 over R? Well, it's because conductance is the opposite of resistance, right? So it's the inverse of resistance. So G is equal to 1 over R, and guess what R is in relation to G? R would be equal to 1 over G, right? So they're both inverse of each other. We won't be messing around with conductance too much. I just wanted you to be aware of it. All right, we're gonna move forward. Oh, you know what? Before we move forward, let me outline the main formula that we're gonna be dealing with. This is the main formula right here. V is equal to I times R. I is equal to V over R. And don't forget how we figured it out, right? If you're looking for I, you go to this triangular chart, you cover up the I with your finger, whatever it is, and then you're left with V over R. Now, the formula for resistance is V over I. Again, don't forget how we found it. You go to the resistance in the chart, you cover up the R, which is what's right here, and what you're left with V over I. So that's what we did. Did V over I. Let me just make this a little bit clearer. V over I. Alright, so now let's apply these formulas on a circuit. Let's do it. You know what? Let's do this one first. Let's do this guy first. Alright? The proper method of doing this is the first things first. When you look at a circuit, you identify all the variables. So we have V here, question mark. That means this is something that we have to find. Then we have our I, right? What does I say? 22 milliamps. 22 milliamps. So at this point in your head, you need to be converting this in a decimal form so you can put it into a calculator properly, accurately. Next, we have our resistance. Right? What's my resistance? 500 ohms. How do I know this is my resistance? Well, look at the unit. The unit will tell us. All right. Once you have done that, once you have established, identified all the variables, we'll do a given and find setup. So, given and find. It's basically a chart that lets you identify all the pieces. So what's given in this circuit? Well, given is I, right? You can see I is given. What's my I? I is 22 milliamps. What else is given? Well, my R is given. We have a value for R here. R is 500 ohms. What do we have to find? What is the missing piece? Well, clearly, the voltage is a question mark instead of voltage, so we gotta find the voltage. My voltage is a question mark. Now that we know what we have to find, let's set up the circuit. Well, the circuit is already set up. Let's set up our equation. All right, this is step one. Step two is figuring out the formula. We already know what the formula for V is, right? It's right here. So V is equal to I times R. Now what do? Well, we substitute for these values. What is the value for I? It's right here. The value for I is 22 milliamps. How do we express 22 milliamps in decimal form? All right, here we go. 0.022. Let's work it out over here. So you have 22 milliamps, right? Milli is 10 to the negative 3. That means you must move the decimal point 3 times. Now, where is the decimal point in this number 22? It's at the end. If you can't see it, it's always at the end. So we move it 3 times. 1, 2, and 3. Wherever there's an empty cup, we fill it up with a 0. Put a 0 there. Alright, there we go. So now we have our current. What is my resistance? Well, 500 ohms right there. 500 ohms. Alright, so this is my equation. This is the substitution. Now we can figure out the voltage. Let's put it in the calculator and see what we get. Alright, I got my answer. Did you get your answer? Can you tell me what it is? I got 11 volts. Can you verify that for me? Did you get 11 volts as well? I hope you did. So this is the setup for this is a proper way to solve a circuit using Ohm's law. Alright, now let's try to solve this problem right here, this bad boy. What's my first step? Let's identify all the pieces that are given and that we have to find. So my voltage is given here. All right, what's my voltage? 16 volts. My current is given here. What's my current? 40 microamps. Resistance is a question mark next to the resistance, meaning we gotta find the resistance. All right, so let's set up a given and find chart for this guy. Let's do it here. Given, all right, and find. Given and find. So what's my given? My voltage is given. I write it down. V is 16 volts. My current is given, right? I is equal to 40 microamps. And what do we have to find? Resistance. I gotta find my resistance. Now, let's look for the formula for resistance. Where is my resistance? Where is my resistance? Can you guys find my resistance formula for me? Alright, here we go. This guy right here. Let's get it. So my resistance is supposed to be anyways. R is equal to V divided by I. Now what do? Well, we substitute. What's the value for V? The value for V is 16 volts. What's the value for I? 40 microamps. What is 40 microamps? How do you figure out what 40 microamps is in decimal? Let's do it together. Alright, so we have 40 micro. Micro is 10 to the negative 6, right? That means we have to move the decimal 6 times. Now, where's the decimal here in the number 40? Is it before the 4? Is it between the 4 and the 0? Or is it after the 0? Well, if you cannot see the decimal, it's always going to be at the end of the number, which is here. So now we move it 6 times to the left. Let's do it. 1, 2, 3, 4, 5, and 6. All the empty cups, empty spots, we put a 0 in. Fill it up with a 0. Fill it up with a 0. And we have 4 zeros. So we'll have point, 4 zeros, and then 40. Now I could put a 0 here if I want to. I don't really need the 0. It doesn't really matter. Alright, so what's my answer? What do we get? Did you guys get it? Did you figure it out? What did you get? What did you get for resistance here? Well, I got 400k ohms. 400k ohms. Alright, that's what I got. Is that what you got? Well, please verify. Right. Maybe you got 0.4 mega ohms. Right? That would also be correct. Let's move on to another circuit where we need to find the current. Let's move it up here, and there we go. So here we are missing current. There's a question mark next to current. We're given the voltage and we're given the resistance. Let's do this. Let's do this together. We'll set it up over here. So the given and find method. How do we do it using the given and find method? Well, let's just list it under G for given and find, F for find. All right, G and F. So what's given? My voltage is given, right? It's 18 volts. My resistance is given, right? How much is my resistance? 120k ohms. 120k ohms. It's a lot of resistance. And what do we have to find? Well, in this case, we're finding I, and I is for current. Now, what's my formula for current? How do I find I? Well, we know it from the past. I is equal to, you guessed it, V over R. Alright, now let's substitute for our voltage and our resistance. So I is going to be equal to, my voltage is 18 volts, right? 18 volts. By the way, we're doing this problem right now. That's the one that we're doing, working on. My I is equal to 18 volts, that's my voltage. And what's my resistance? 120k. What does 120k ohms look like in decimal form. It looks like this, right? So let's work it out over here. If you have 120 k ohms, right? What's k? K is 10 to the third. Sorry guys, a little messy here. But you move the decimal 3 times to the right. 1, 2, 3. And you end up with 3 zeros. So what's my answer? What is my answer? What is my current? Here, what is my current? Can you guys tell me? So I got point 15 milliamps. That's what I got. Maybe you got something like 150 microamps. Either way, correct answer. Alright guys, so as I was saying, um, why don't you guys work on this problem right here? Alright? Do it on your own. Use the given and find method. Alright? Use your calculators. Identify all the variables, the values, and solve it. And that'll count towards your bonus points, and I'll share the answer with you towards the end. Right. We'll move on to phase 2 of Ohm's law, which is understanding word problems. Alright? So let's get to it. I have these 3 word problems here. Random numbering 4, 5, 6. Let's start with 4. Alright? And see how we can break it down. Let's read the question first. You gotta read the question carefully. There's some vocabulary terms here that might be new to you guys. What current is carried by a 27 ohm? Right? Look, this is a value. It's giving us a unit, so we must be able to recognize what this unit is for. And what current is carried by a 27 ohm line cord resistor if the voltage drop, new term, voltage drop, what does this mean? If the voltage drop across it is 40.5 volts, right? Another value, the unit. Voltage drop, what does voltage drop mean? Voltage drop just means voltage, right? The fancy way of saying voltage. So when you see the word voltage drop, they want to know the voltage or they're giving you the voltage. It's one of those two things. Let's do the given and find method. Let's set this up. So G, F, alright, what's my given? 40.5 volts, that's the voltage of course. 40.5 V. And I have my ohm symbol here, that's my resistance obviously. 27 ohm. What am I looking for? What am I looking for? What do I have to find? Bang, the current, the letter I. Alright, so let's set up the formula for the letter I. Current, what's the formula for current? I is equal to V for R, right? What's my V here? 40.5. You should have your calculators out. Alright, my resistance is 27 ohms. So, what is my answer? Let's put the value in the calculator. And what do you guys get? What did you guys get? I got 1.5 amps. Is that what you got? Once you get your answer, you box your final answer. Right? Always box it so I can see what your values are. Alright, hope that was easy for you guys. Let's move on to something a little bit more, well, it's also easy. This is not easy as well. It's just the vocabulary tool here. Let's just get over that hurdle first. Let's read the question first. What is the hot resistance? What the hell is a hot resistance? What is the hot resistance of a light bulb? It draws 750 milliamps from a 120 volt line. See these values right here? What do these values indicate? Which variables do they belong to? Alright, let's work it out. Let's do our given and find method. We'll do the circuit in blue. Given and find, right? G and my F. My given. What are my givens here? 750 MA. What is that for? The I, of course, right? 750 MA. The A tells you. The A here tells you is for current. Alright, what else is given? Well, there's a V. What does a V mean? V means voltage. Alright, and what are we looking for? Hot resistance. Guess what hot resistance means? Just resistance. Just plain OR. Plain or resistance. So, how do we find resistance? Right? How do we find R? Well, R is equal to V over I. Alright, what's my V? My V is 120. What's my I? My I is 750 milliamps. What is 750 milliamps in decimal form? So milli is -3, right? -3. Decimal, where's the decimal here? Right here. At this point, you should all know where the decimal is. Decimal is right here because, well, you should know why. We'll move it 3 times to the left. Boom. And we end up here. So my answer is going to be 0.75. You don't have to write the 0. You can if you want to, but you don't really have to. So 750 milliamps is equal to 0.75 amps. So what's my resistance now? Well, work it out. Use your calculators. What did you guys get? I got 160 ohms. That was my resistance. What did you guys get? I hope you guys got the same thing. Okay, what I want you to do now is I want you to work on this guy right here. Number 6, right? Solve number 6 on your own. I'll give you guys a little bit of time to solve it and you work it out. Alright? Alright, so as I stated, I wanted you guys to find a solution for number 6 and a solution for this guy highlighted in purple, right? This circuit right here. So we'll scroll up to get the answer, and the answers to your bonus points are the following. Alright, they're right here. For the circuit, it should be 16.5 volts. For the word problem, it should be 75 volts. And with that, I bid you goodbye. See you guys soon. Take care.